Math 1332, Consumer Mathematics, Section 4, Compound Interest, Video 7, Finding the Monthly Payment for an Annuity. Or as I like to call it, the annuity formula backwards. Because in the previous video, we basically said, if I make this much payment per period, how much will I have at the end? But sometimes you need to flip that around and say, I need this much money at this point in the future. How much should I make on regular payments now to get to that goal? When you buy into an annuity, you are sometimes constricted by how much you can pay each period, but sometimes you buy into an annuity with a certain goal in mind. For example, let's say you own a business and you want to make some future improvements to the office space you currently have. You may have an idea of how much you will need to make those improvements, but you cannot afford to pay all of the cost up front. Instead, you decide to buy into an annuity with a desired future value. How can you determine the periodic payments you would need to make in order to reach that desired value? Luckily, we already have a formula that relates the periodic payment. I should say periodic right there. Periodic is just like the word regular. The main difference is, from a mathematical perspective, periodic means occurring on the same time intervals. So monthly is periodic, as opposed to random payments that you pay whenever. But luckily, we already have a formula that relates the periodic payment R to the future value A. If we can solve this formula so that it says R equals, then we have exactly what we want. And in general, that's a good math strategy. If I want to know what something equals, I need a formula that says that equals something. But right now, our formula says A equals R times double open parentheses 1 plus R over N, all to the NT power, minus 1, close that parentheses, and over R over N. And notice I didn't put the extra parentheses around it yet. I could, but I'm not going to. Well, actually, I think I will around the denominator, because I want to show you how to think of things a little bit more globally from an algebra perspective. And I really don't think it's that hard to make this formula say R equals. Remember, if we can make it say R equals, then we have exactly what we want. Give me 1 second to reposition some of these things. Okay, you may be thinking you really didn't do much. You just moved it over some, but there's a method behind my madness. We want this formula to say R equals, and the R is currently parked right here. From an algebra perspective, when you want to isolate a letter, you ask yourself 2 questions. What's attached to it? Or 3 questions. What's attached to it? How's it attached? And how do you get rid of that thing? Let's start with the denominator. Now, in the denominator, there's a fraction, but I see it as its own entity. And in the numerator, there's a lot of stuff after the R, but if you look closely, the numerator is just R times that thing. So whereas you may see R's in parentheses and little R's and N's and T's and ones and pluses and minuses, what I see is the thing in yellow times the big chunky thing in blue divided by the thing in green. And I want to get the thing in yellow by itself. So we got to get rid of the thing in blue and the thing in green. I'm going to start with the thing in green. The thing in green is attached to the thing in yellow by being divided into it. Yellow divided by the green thing on the bottom. So if we wanted to get rid of the green thing on the bottom, we can multiply both sides by that. Now, I'm not going to redraw it, but let's just pretend for a second that we multiplied by that thing here, and we multiplied by it over here. Actually, I would like to put it on the left side of the A, excuse me, the right side of the A. So give me 1 second to grab that A, move it over, grab this green thing, move it over. So all I'm doing is repositioning things. All right, so as I was saying, really all we're doing right now is trying to get rid of the green thing on the bottom of the fraction on the right. So if we multiply both sides by that, then that will give us enough ammunition to go adios to you. So that would kill the green thing on the right. So let's get rid of it. But it would make it show up on the left. So I'm going to capture all this and just put it over here. All right. And at that point, we don't need the fraction bar on the left, so we'll get rid of that. And now all I have to do to get the r by itself is to get rid of the blue thing that it's multiplied by. Well, how do you get rid of something that's multiplied? You divide. So we are going to divide both sides of this by the big blue box. And again, I'm not going to write everything in there. It's not the same shade of blue as I used before. I know that sounds nitpicky, but and if we divide both sides by that big blue box, then that gives us enough ammunition to do this. And that will get the r by itself. So let's cancel everything that I just crossed out. You won't need you anymore. We won't need the fraction bar. But instead of canceling this guy out, it's going to essentially move down here. And now let me get rid of the green box and the blue box, and I guess the yellow box too. And just like that, we have a formula that says R equals. If you followed that, great. If you didn't, guess what? You're going to be fine, because all you really need to know is how to use this formula. I'm going to write it on the next page a little more cleanly. I forgot I had already written it there. So here's the formula for finding the monthly payment for an annuity. Suppose you pay into an annuity. You make N payments per year. The interest rate is lowercase r. The term of the annuity is T years. You want a future value of A. Then the required periodic payment, R, capital R, needed to get the desired future value is, and I'm going to highlight it as I read it. R equals A times, parentheses, little r over N, divided by, double open parentheses, there's the first one, there's the second one, parentheses 1 plus r over n to the nt power, the compound interest formula, minus 1. Now, being a big fraction, you need to be very careful with the parentheses. Notice the numerator is more than a single number. So we're going to put an extra set of parentheses around the numerator. Technically speaking, they're not necessary, but it's a good thing to practice. And in the denominator, we also have a really big chunky thing. And we could put an extra set of parentheses around the denominator. But notice that the way the formula is written, it already has a set of parentheses around the entire denominator. So there's no need to throw an extra set of parentheses around it. However, the exponent is still more than a single number, so I'll put parentheses around that. So if you're going to write the formula down, I would write it like this. You know, in retrospect, well, I'm not going to take off the red parentheses on the top, but knowing what I know about the order of operations, they're not necessary. But to repeat something I said in a previous video, if you're debating whether or not to put parentheses around the side of a fraction, there's no harm in putting them there if they're not necessary, but there is harm in leaving them out if they are. So the safer thing to do if you're not sure is to go ahead and put the extra set of parentheses around the side of a fraction if you're not sure. It will never be wrong to put them. It could be wrong to leave them off though. All right, so let's go back to the aforementioned business, or as I like to say, the AO-free mentioned business. The aforementioned business needs $1 million for improvements. And I'll be honest, that's probably kind of on the low side. They plan to buy into an annuity that pays 6.5% interest. I'd like to find that interest rate. What should their weekly payments be in order to have the $1 million in 5 years? I want you to see if you can guess. How much do you think they have to pay per week for 5 years to wind up with $1 million? Just what do you think? Just throw a number out there. And now let's figure it out. All right, let's start with the information that we're given. The first thing we're given is that they need a future value of 1 million. So our A is equal to 1 million. The next piece of information we're given is the interest rate, lowercase r, 0.065. What should their weekly payments be? There's the number that's not a number. N is the number of times per year you make payments. If we're making weekly payments, we can assume 52. Although there's not exactly 52 weeks in a year, a year is 52 weeks and 1 extra day. We'll just say 52 weeks in a year. and the term is 5 years. And the question is, what is the periodic payment? In this case, what is the weekly payment? All right, we got a formula. Here it is. So let's set it up. Our weekly payment is going to be $1 million. Almost had not enough zeros there. That's only off by a factor of 10. Times little r over n, so 0.065 over 52. And the denominator, it's a double open parentheses, 1 plus little r over n, exponent n times t is 5, minus 1, close parentheses. And we'll go ahead and throw the extra parentheses on the top. Technically not necessary, but better safe than sorry. And how would you put this into a calculator? The battle here is, half the time is, how do I press the buttons on a calculator? We'll literally just go left to right, top to bottom, don't forget the big fraction bar in between, and type what you see. So what I see is in the top, parentheses, 1 million. Don't forget to count your zeros. There's 6 of them. And 1 million times, open parentheses, 0.065 divided by 52. Close the black parentheses on the right side of the fraction. Close the red parentheses on the top of the in the numerator. Divided by, don't forget this fraction bar in the middle. Get the feeling I'm going to run out of room. Double open parentheses, 1 plus 0.065 divided by 52. Close parentheses. Let's go ahead and go down here. Open parentheses, exponent. Open parentheses, 52 times 5. Close parentheses on the exponent, minus 1, close parentheses on the denominator. Now, like I said before in the previous video, it's a good idea to write down what you're going to put in your calculator because it helps you focus, because it's a long problem you're putting in your calculator. Plus, on a test, if you write down the calculator keystrokes correctly and get the wrong answer in your calculator, I can give you lots of partial credit. All right, so this time I'm going to call it out as I type it in. All right, parentheses 1, 0, 0, 0, 0, 0, 0 times, open parentheses, 0.065 divided by 52, double close parentheses, divided by, double open parentheses, 1 plus 0.065 divided by 52, close parentheses once, exponent button, open parentheses, 52 times 5, close parentheses once, minus 1, close parentheses, and then press equals. To the nearest cent, I got $3,257.33. I'm going to pause the video and put it in a different calculator just to make sure I didn't make a mistake. And I got the same answer. All right, so they only need to make a weekly payment of $3,257.33. Can the business afford that? I don't know. I don't know what their bottom line is, but what would you rather do? Make a bunch of payments of that or put down the $1 million up front? That might be a manageable weekly payment for this business. All right, and this not only wraps up the video, but it also wraps up this section about compound interest.